All right, how's it going, guys? Today we're going to be going over module 4.4, day 2, solving real-world problems using quadratic inequalities. It's going to be very similar to how we normally solve quadratic inequalities, but the only difference is we have to take the context of the problem into account. Okay, so we're still going to write the inequality, and then we'll rewrite the inequality with a 0 on one side because a quadratic will not work. A quadratic function will not work unless you have a 0 on one side. And then we're going to solve accordingly, and we're going to be sure to check for the reasonable solution, all right? For instance, you can't have a negative distance or a negative time, right? So we have to make sure that our solution actually matches with the problem. Okay, so example 1, we're told there's a football is thrown by a quarterback and it follows a path given by the equation y equals negative 0.01 x squared plus 0.8 x plus 7, where x and y are measured in feet, and the origin is on the football field directly below where the quarterback releases the ball. In other words, the origin, or the 0, 0, is right underneath the quarterback. If the ball can be caught or knocked down at any height less than 10 feet, at what distance from the quarterback can the ball be caught or knocked down? Okay, so the important piece of information in this problem is going to be the quadratic equation, and it's going to be this little segment right here, at any height less than 10 feet. So the quadratic expression, or the equation, is telling us the height of the ball, how high it is, and how far it is away from the quarterback. And we want to know when the height is going to be less than 10 feet. The y is telling us the height, so we want to know when y is less than 10, or in other words, when negative 0.01 x squared plus 0.8x plus 7 is less than 10. We want to know when the quadratic expression is less than 10. So we need to set this equal, or sorry, not set equal to 0, but we need to have a 0 on one side. So we're going to minus 10 on both sides, and we get negative 0.01 x squared plus 0.8x, and 7 minus 10 gives us a minus 3, and that's going to be less than 0. Okay? So once we have our inequality with a 0 on one side, what we're going to do is that we're going to put it into our quadratic formula, and we're going to see what our critical values are. All right, so it's negative b, so we have negative 0.8 plus or minus the square root of b squared, which is going to be 0.8 squared. The negative is kind of redundant. It goes away regardless. Minus 4 times our a of negative 0.01 and our c of negative 3. And all of that is going to be over 2 multiplied with our a. Okay? So if we solve this out, we get negative 0.8 plus or minus the square root of 0.52 all over negative 0.02 or 0.02. And if you solve this out and you get your two solutions, we're going to get our x values to be approximately 4 and 76. If we're rounding the whole numbers, we're going to get approximately 4 and 76. So our critical values will be 4 and 76. All right? So now what we want to do is you want to see where are our solutions. Are they in between the critical values, or are they outside of the critical values? So we need to pick a point or a number either between them or outside of them, and we're going to see if it makes any sense in context of the inequality. All right? For a problem like this, I see a lot of decimals. I'm going to go with 0, regardless if it's between or outside. And 0 happens to be outside of the critical values, so let's take 0 and put it into our inequality and see what we get. We plug in 0 to our beginning inequality, we get negative 0.01 multiplied by 0 squared plus 0.8 multiplied with 0 plus 7 is less than 10, or really all it says is 7 less than 10. 7 is indeed less than 10, so that tells me my my solutions are going to be outside of the critical values. 0 is a number outside of the critical values. When I plugged into the inequality, it made sense. So that tells me the solutions are outside of the critical values. Okay? So that means x will be less than 4, and x will be greater than 76. This is my solution set, right? But it's just our solution set, but it's not our actual answer. All right? Because we need to make sure it makes sense in the context of the problem, which it doesn't fully make sense, because when x is less than 4, that's also including negative, the negative numbers. You can't have a distance of a negative, so it doesn't really make sense in the context of the problem. So we need to kind of relate it back to the problem to see what our actual reasonable solution to this inequality will be. All right, so the ball's path begins at x equals 0. Remember, we said the quarterback is standing right over the origin, so the ball's path begins at x equals 0. And it's going to end when the ball hits the ground, right? The ball cannot go underneath the ground. It's just going to, the play is going to end as soon as it touches the ground, and that's where our quadratic ends for this problem. So we need to find out how far the ball is from the quarterback when it hits the ground. So we're going to set y equals to 0 because y is the height of the ball. So we want to know when y equals 0. So in other words, we're going to set the quadratic that tells us about the ball's path, and we're going to set it equal to 0. And then we're going to solve. Okay? So we're going to put that into our quadratic formula, and we get negative 0.8 plus or minus the square root of b squared, which is 0.8 squared, minus 4 times our a, which is negative 0.01, and our c, which is 7. All of that divided by 2a, or 2 multiplied with negative 0.01. And once again, if you put this to the calculator, you solve it by hand, whatever you do. If you solve it out, we get our solutions to be x equals negative 8 and x equals 88. These are the solutions we get if we solve out this quadratic. Okay? So now when's the ball going to hit the ground? It doesn't make sense for the ball to hit the ground when x equals negative 8. You can't throw a ball forward and it falls and it hits the ground behind you, since the origin is where the quarterback is. So it doesn't really make much sense, right? So we know the ball hits the ground when x equals 88. That's when it makes sense. Or approximately 88. I think that's a better way to say it, because these are all basically approximations, and that's what they'll approximately be. So a reasonable solution to this inequality, we're going to take what we know here, that the ball's path begins at x equals 0, ends at x is about 88, and our solution set that we solved on the previous part, and we're going to put them together. All right? So we know x has to be greater than 0, but at the same time, it has to be less than 4. And at the same time, x has to be less than 88, so that's where it ends, and it has to be greater than 76 from our solution set, right? So the ball will be under 10 feet when x is between 0 and 4, and 76 to 88, or when the ball is less than 4 feet away but greater than 0 feet away from the quarterback, and from 76 feet away from the quarterback and 88 feet away from the quarterback. That is when the ball is under 10 feet high, and the ball can be caught or knocked down. Okay, so let's go on to number 2. Number 2, we're told the club charges $12 annual dues and has 1,000 members. A survey of the members indicate that for every $1 increase in the annual dues, the club will lose 40 members. This means that the revenue, R, from dues, which is currently $12,000, will become RD equals 12 plus D times 1,000 minus 40D, which equals the quadratic negative 40D squared plus 520D plus 12,000, where D is a whole number of $1 increases in dues. For what amount can the dues be increased so that the revenue for the dues will be at least $13,000? We see these words right here will be at least $13,000. That tells me that the revenue has to be greater than or equal to $13,000. And our revenue is given by negative 40D squared plus 520D plus 12,000. So our inequality will be negative 40D squared plus 520D plus 12,000. All of that has to be greater than or equal to 13,000, because we want the revenue to be greater than or equal to 13,000. All right, so we need to make our inequality have a 0 on one side. So that means we're going to minus 13,000 on both sides, and we'll get negative 40d squared plus 520d minus 1,000, because 12,000 minus 13,000 gives us negative 1,000. And all of that will be greater than or equal to 0. So what we see here now is a new inequality. There's some very big numbers, but something we see is that the negative 40, 520, and the negative 1,000 are all divisible by 40. So we can actually reduce this and make it a little simpler for ourselves, and we can divide everything by we can divide everything by negative 40. So negative 40 divided by negative 40 will give us a positive d squared. 520 divided by negative 40 will be negative 13d, and negative 1,000 divided by negative 40 will give us a positive 25. And since we're dividing by a negative number, we're going to flip the inequality sign and make it less than or equal to 0. So we have our simplified inequality. So what we're going to do now is that we're going to find our critical values, and we're going to figure out what our solution to this inequality is going to be. So we're going to use our quadratic formula once again. Negative b is 13 plus or minus the square root of b squared. 13 or negative 13 squared doesn't matter. The negative goes away regardless. Minus 4 times our 1 times our c, which is 25. All of that, all over 2a. Our a is 1, so we get 2 multiplied by 1, or just 2. Once again, we're going to solve this out. If you solve it all out, we get our d to be approximately 2.35 and approximately 10.65. These are just approximates. It's going to be give or take this depending on how many decimal places you want to round to. In this case, we're rounding to the hundreds place since we are dealing in dollars. So it makes more sense to round to the hundreds place. Okay? So now we need to figure out where is our solution. Is it in between those two critical values, or is it going to be outside of those two critical values? I'm going to use 0 again. I think 0 is a very, very good number to use. It cancels out most of the inequality. So I'm going to use 0, and 0 happens to be outside of the inequality, or outside of the critical value, sorry. So if I plug in 0 into either inequality, they will both work. For the first one, I get negative 40, 0 squared, plus 520 multiplied by 0 minus 1,000. It's greater than or equal to 0. This negative 40 multiplied by 0 squared goes away. Same with this, and we're left with negative 1,000 is greater than or equal to 0. That doesn't make any sense. Negative 1,000 is not greater than 0. So that tells me that our solution is going to be in between the two critical values. Okay? So we know our d will be in between our critical values. But before we actually write out our solution to the inequality, we need to double check our critical values, our solution, to see what actually makes sense. Okay? So we're told our solution is, we're told in the problem that they can only increase the dues by $1 increments. So we can't actually increase the dues by $2.35. We have to either increase it by $2 or $3. So remember the inequality. We're told that we want to increase it. And we want to have, we're going to have a revenue of at least $13,000. So that means, and what this D equals 2.35 tells us is that we have to increase the dues by at least $2.35 to make a revenue of $13,000. Anything below that, we're not making $13,000 anymore. So in this case, we have to round up to 3. Anything less than $3, we're not making that revenue of $13,000 that we want. And so if we go to 2, we're not going to have that $13,000. That doesn't work with the inequality. So with 10.65, we're going to think about it the same way. Anything above 10.65 is good. We're going to be losing too many members. We're not actually going to be making the revenue of $13,000 that we want. So that's why for 10.65, we're going to round downwards to 10. Because anything more than 10.65, we're losing too many members. We're going to have a revenue less than $13,000 that we want. So that's why we round that down and why we round to 2.35 up. So our solution to this problem with the inequality is 3 has to be less than or equal to D, which is less than or equal to 10. So we have to increase the dues by $3, $4, $5, $6, $7, $8, $9, or $10. Anything between that, any of those numbers will give us a revenue of at least $13,000. Okay? We have one more problem. Let's get it done. All right, so a person on the ground outside a building throws a set of keys up to a person on a second floor balcony. The ground person releases the keys with an initial vertical velocity of 28 feet per second from a height of 4 feet. The function h of t equals negative 16t squared plus 28t plus 4 models the height in feet of the keys at time t in seconds. After the keys are thrown, the person on the balcony can catch the keys once they reach a height of 14 feet. For what period of time are the keys high enough to be caught? Okay, so we're told that the guy on the balcony can catch the keys once they reach a height of 14 feet. So as soon as the keys hit 14 feet, the guy can catch the keys. So that means that the inequality has to include 14 as a solution. All right, and he can also catch it anything higher than 14 as well. Okay, so our inequality is going to be negative 16t squared plus 28t plus 4. And this inequality, which gives us the height of the keys after it's thrown, has to be greater than or equal to 14. Anything below 14 feet, the guy on the balcony cannot catch it. It's going to be too low for him to catch it. So it has to be 14 feet or higher for him to catch it. All right, so once we have our inequality, we have to have 0 on one side. So what we're going to do is minus 14 on both sides and have 0 on the right side. So you have negative 16t squared plus 28t. 4 minus negative 14 gives us negative 10. It's greater than or equal to 0. We can simplify it some more. So when you simplify the inequality, we can see negative 16, 28, and negative 10 all have a common denominator of 2. So I'm actually going to divide by negative 2 to get the a and the c positive. So I end up getting 8t squared. 28 divided by negative 2 is negative 14t. And negative 10 divided by negative 2 is positive 5. And if you divide by a negative, you flip the inequality. So that becomes less than or equal to 0. 0 divided by negative 2 is still just 0. So, like we always do with quadratics, we're going to put this into our quadratic formula. So negative 14 becomes positive 14. That's plus or minus the square root of b squared, negative 14 squared, minus 4 times our a, which is 8, and our c, which is 5, all over 2a. All right, this one isn't too bad, so we'll do it together. We have 14 plus or minus the square root of negative 14 squared. I think that is 196. It is. We have 196 minus 4 times 8 times 5, which is 160. So 196 minus 160 gives us the square root of 36. All that all over 2a. Our a is 8. I don't know why I put 2a in the beginning, but it is 2a, or in other words, 16. Right? So I'm going to continue this on down here. So you have 14 plus or minus the square root of 36 is just 6, all over 16. And that gives us two different solutions. 14 plus 6 is 20, all over 16. And we have 14 minus 6, which is 8, all over 16. 20 divided by 16 can be simplified to 5 over 4. And 8 over 6 can be 8 over 16, sorry, can be simplified to 1/2. So these are our two solutions, and we need to know where are our critical values, or sorry, our solutions in comparing to the critical values. Are they in between the critical values, or are they outside the critical values? Okay, so once again, you're going to use 0. It's just such a simple number to use. 0 is outside of the two critical values again. So I'll plug in 0 to either inequality, and I'm going to see what happens. I'm going to go ahead and use the first one, negative 16t squared plus 28t minus 10. So just bring it down here. Negative 16t squared plus 28t minus 10 has to be greater than or equal to 0. Let's sub in 0 for our t. Negative 16 times t times 0 squared is just 0. 28 times 0 is just 0. And we're left with minus 10 greater than or equal to 0. Or negative 10 is greater than or equal to 0. Negative 10 is not greater than or equal to 0. That does not make any sense. So that tells me our solutions are not outside the critical values. And if it's not outside the critical values, it will be in between the critical values. Okay? So I know my solution is in between 1/2 and 5/4. But we need to make sure that our solutions actually make sense. And in this case, it does make sense. The time can be 1/2, and it can also be 5/4 or 1.25. That makes sense. So there's nothing actually wrong with our solution. It's just going to be, our answer is just going to be 1/2 is less than or equal to t, which is less than or equal to 5/4. All right, that's what our solution is going to be. There's nothing contradicting between the inequality that we get and the solution that we get, so we're good to go as it is. And that's just what our answer is going to be. All right, there's 2 homework problems for you guys to do. You can go ahead and get started on that. And you can double check your answers with the homework that we have, or the answer key that we have posted up.